All right, so in this lecture, I'm going to be going over graphical solutions for mirror problems. The lecture from earlier today that I recorded with period 0 and 1 is on the mathematical solution for mirror problems. This is on the graphical solution for mirror problems. If you're given a mirror problem, they're going to give you information about the mirror. Then they're going to say, where does the image form? How big is the image? Is it upright or inverted? Is it real or virtual? You can solve these problems mathematically, which is more time-consuming but accurate, or you can solve it graphically, which is remarkably fast but not accurate. It's a trade-off. And you got to be able to do it both ways, because if you look at the free response questions on the AP exam, there's a high probability that they could ask you to do a free body diagram. So graphical solutions, they're referred to as free body diagrams. But before we do that, let's go over the terms you got to know. I did this in the first lecture as well, but it's going to be important here. So look, these mirrors, concave and convex, they're collectively spherical mirrors, right? There's two types of spherical mirrors, concave and convex. Why would we refer to concave and convex mirrors as being spherical? Well, here we have a concave mirror, and it's almost like it came from a sphere, right? You can like extend the circle. Would that circle have a center to it? Yes. And that center is called the center of curvature. Just a term you should know. All right. Would this sphere have a radius? Yes. That's called the radius of curvature. If you take the radius of curvature and cut it in half, take the radius of curvature, divide it by 2, that's called the focal length, which is a big-time term in photography. I'm not a photography guy, but anybody in photography? The focal length of a lens, right? That's the focal length. Half the radius of curvature, focal length. If you go out if you go from the mirror out to out one focal length, that takes you to what we call the focal point, right? So starting at the mirror, you come out the focal length. That's called the focal point. Okay, and then let's see what else. I'm not going to talk about magnification here. Principal axis. The principal axis is this line. It's like an imaginary reference line that goes directly into the center of the mirror. Object distance and image distance. So here we have the object. This arrow right there represents the object. The distance from the object over to the mirror is referred to as the object distance. The College Board uses the symbol SO. I don't know where they get S from, but our textbook, just so you're aware, if you're using the textbook does P and Q for those symbols, which is even more odd. I don't know where they got P and Q from. Okay, and then what's image distance? Right here's the image. The image distance is simply the distance from the image to the mirror. That's it. So the terms you really got to know for ray diagrams, you got to know center of curvature and focal point. Those are the two big ones. All right, so let's look at ray diagrams. Okay, so ray diagrams for mirrors. So a ray diagram, it's a graphical method of solving mirror and lens problems. Tomorrow I'm going to go over lenses. What's the key difference between a mirror and a lens? Light can go through a lens, but not through a mirror. Light will reflect off of a mirror. Okay, so the 3 rays of a ray diagram are like this. Here are the 3 rays. And I want to mention, when you're doing a ray diagram, you actually only need 2. You only need 2 of the rays, and then what's the purpose of the third one? To check your work. All right? The third ray will function as a check. If your third ray does not agree with the first 2 rays, then you made a mistake. Okay? So let's go through these rays, and then I'm gonna show you how to do it. By the end of the lecture, you should have the hang of it. Okay, so ray number 1. Oh, and actually I forgot to mention one other thing. Guys, kids often think that like in real life light rays do this. Like the three light rays get together and they're like, okay, so you be ray number 1, you be ray number 2, and then I'll be ray number 3. Ready, set. Do light rays actually do that? No, they don't. These three rays are, it's a tool that somebody very smart came up with. And every year I teach it, I'm amazed that it works. Because what you find out from your ray diagram should agree with your calculation. Whether you calculate the answer or do ray diagram for the answer, the answer should agree. Okay? So these three rays are simply a tool. Okay? In real life, light rays don't, this one goes here, this one goes here. This is a method for finding out information about the image formed by a mirror. Okay, so ray number 1. Let's clear this up. Ray number 1 goes parallel to the principal axis, reflected back through the focal point. Now, to help you remember this, I like making things easy. Just remember this. It goes parallel, then focal point. Parallel, focal point. What does ray number 2 do? Ray number 2 does the opposite. Focal point, and then parallel, right? So that's what you want to put in your head. Okay, the first one goes parallel, focal point. The second one goes focal point, parallel. They're the opposite of each other. Okay, so let's look at these two rays. Ray number 1 goes like this. So from the tip of the object, now actually here's a question that comes up. Spaldo, why are you doing the ray diagram from the tip of the object? This is the object right here. Could be a book, could be, a water bottle, could be my coffee mug, whatever the object is. Why do we do a ray diagram from the tip of the object? Well, the answer is because that's going to lead us to where? That's going to lead us to the tip of the image. I mean, could we have done the ray diagram from the middle of the object? Yeah, but then where's that going to lead us to? The middle of the image. I think it's better to find the tip of the image. You know what I'm saying? All right, so go from the tip of the object. So ray 1 goes like this. It goes parallel. So see right here? Parallel to the principal axis, reflects off the mirror through the focal point. See, there's the focal point right there. Through the focal point, and then bam, that's it. That's ray number 1. Okay, now what does ray number 2 do? Ray number 2 does the opposite. It goes focal point and then parallel. So ray number 2 goes like this, bam, through the focal point, hits the mirror, reflects off, and goes parallel. Right? We just found where the image will be. The image will be where those light rays intersect. Where does light ray 1 and light ray 2 intersect each other? Right there. And that's where the image will form. It's pretty bomb. The fact that that works. Every year I'm like, dang, whoever came up with this method, smart. Like, seriously, how did the person... Anyway, let's keep going. Okay, now, ray number 3. Ray number 3 is a check. If ray number 3 does not agree with what we just found, then you made a mistake somewhere. So ray number 3 goes through the center of curvature and then reflects back on itself. So it hits the mirror and then comes straight back. So see, ray number 3 goes like this. Into the mirror, through the center of curvature right there, to the mirror, bam, and then comes straight back. Does that agree with what we found? Yep. Okay, and look, we just found out a bunch. Now, for starters, is the image bigger or smaller than the object? Smaller. Is it in front or in back of the mirror? In front. This is the front side. Over here is the back side. It's in front of the mirror. Is it upright or inverted? It's inverted. Hey, whenever your rays intersect below the principal axis, it's going to be inverted. If it's upright, the rays would intersect above. If the rays intersect above, then it's upright. Okay? What else? So it's in front, it's smaller, it's inverted. Okay? Now, this kind of makes sense? Now, one thing you're going to have to know is whether images are real or virtual. Okay? So, and as we go through this, we're going to do the 3 possible ray diagrams for mirrors. There's only 3. There's 3 possible, and we just did the first one. So look, when you do your ray diagram, you'll be able to figure out if the image is real or virtual. Now, what's a real image? A real image is formed by the actual intersection of light rays, like we just saw on the previous screen. Did those light rays actually intersect on the previous screen? Yeah, they totally intersected each other. That's a real image, okay? Real images can be placed on a screen. Like sitting here in this room, my projector there, the image formed by the projector, can that be put on a screen? Well, yeah, that is a screen, and the image is there. That's a real image, dude. See, I put my paper there? If you can put the image on a piece of paper, it's a real image, okay? Now, virtual images, and this will make sense when I show you one, when we do the ray diagram, and then I'm going to get the demo mirrors from Greenberg, and I'll show you this for real. Oh, get it? For real? Virtual? Anyway. Virtual images are formed by the apparent intersection of light rays. But the light rays don't actually cross. They do not actually cross. They just appear to cross. So keep that in mind, apparent, and you'll see it when we get to it. Now, can virtual images be placed on a screen? No. So let's do it. Okay. Okay, so this is the one we just did. So guys, here's the situation. So there's 3 possible ray diagrams for mirrors. There's only 3. There's 2 for concave and 1 for convex. So the first situation is concave mirror with object outside the focal point, as opposed to object inside the focal point. In here would be object inside the focal point. So the 3 rays, so take like 1 minute to sketch out the 3 rays. Try it in class. I'm going to pause the video. Starting from the tip of the object, so what does ray number 1 do? Ray number 1 goes parallel. Shh. So I can draw a nice straight line. So here, put arrows on it, showing the direction. So this ray goes parallel to the principal axis, reflects off the mirror, and goes through the focal point. That's what ray number 1 does. Okay? So we'll label this ray 1. Shh. Now, ray number 2 does the opposite. So start at the tip of the object here. Focal point. Bang to the mirror. Put an arrow on it. If they give this to you on the AP test, put arrows on your rays. So then it reflects off the mirror and goes parallel, like that. Okay, so that's ray number 2. We just found where the image will be. The image is going to be right there. So this arrow here, this represents our image. Is this a real image or a virtual image? It's real. What makes this a real image? The light rays actually intersect. If you stuck a piece of paper right here, and I'll show this when I get my demo mirrors tomorrow, I'll show this to you. You can actually, like, take the trees outside the window, hold the mirror up, you put a piece of paper in front of the mirror, and you can capture the image on a piece of paper. Real images can be put on a screen. Okay? Third ray is our check. So the third ray goes from the object through the center of curvature. Oh yeah. Look at that. Is this agreeing? Does that agree? Yeah. Yes. Look at, so the ray comes in, hits the mirror, and then goes straight back. That perfectly agrees with the first 2 rays. It's money. That's a ray diagram. Dudes, so what did we find out about this image? It is front side of the mirror. It is smaller than the object. It is inverted. It is real as opposed to virtual. Okay, next situation. We got 2 more situations, and then we're done. Revert to say, oh, no, I meant. Okay, situation number 2. Concave mirror, but the object is inside the focal point. The object is now in here. So same 3 rays, but this is going to break your brain a little bit. It's not going to be as straightforward as the last one. So take 90 seconds. Okay, so here's how we do this one. First ray goes like this. So do from the tip of the object, because that'll lead us to the tip of the image. So the first ray goes like this. Just bang, parallel into the mirror. Parallel, so put arrows on it like that. So it goes into the mirror. Then what? Through focal point. So line that up with focal point. Put arrows on it. If they give this to you on the AP test, put arrows on it, dude. If you're just using this on the multiple choice, and it's just you and nobody's going to see your work, then you can just do it however you want. Okay, so boom. Parallel, focal point. Now, what does the next ray do? The next ray might have been a stumper, because what you got to do is you got to imagine a ray going like this. The ray is going like this, through the focal point, bang, up to the mirror like that. You got to line up the 2 points. You got to line up, tip of the object and the focal point. So you want this ray to be like this. You want it to be like that, bang, like that, right? Although you don't have to show this part. Oops. This part here, you could leave that part off. You're lining up the tip of the object with the focal point. Okay, so that ray comes in, hits the mirror, and then what? Goes parallel, right? Focal point, then parallel, like that. You guys with me? Any questions on that? So we went like this. We went parallel, focal point, then we went focal point, parallel, like that. Okay, guys, will ray number 1 and ray number 2 ever cross each other? Never. So it's not going to be a real image. It's going to be virtual. Now, how do virtual images work? It's like this. It's real simple. Look, here's how it works. If your eyeball, I want you to imagine that this is you. If this represents your eyeball right there, where does your eyeball think that this ray came from? Straight back, like that. If this were your eyeball right here for ray number 2, if this represents your eyeball, where does your eyeball think that this ray came from? Straight back. So are these actual light rays? No. What these tracebacks are, the dot, 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 is it shows where light rays appear to come from. Okay? So we just found where the image is. The image is going to be right there. Is it a real image or a virtual image? It's virtual. Because the light rays don't actually cross. They appear to cross. But they don't. Because is there any light back here? Behind the mirror, is there any light? No. But it appears that there is. Okay, third ray. Let's do third ray as a check. Third ray, what you do is center of curvature in the tip of the object. Line that up. So what this ray does is it goes in and then comes straight back on itself. So if your eyeball were right there, where would your eyeball think that this ray came from? Dot, 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 like that. And they all agree. Isn't it amazing? It's pretty cool. Okay, last possibility. Last one. Convex mirror. And there is no inside focal point, outside focal point, because the focal point's behind the mirror, right? So you're not going to take this object and stick it like back here, because that wouldn't make any sense. You're not going to put the object behind the mirror. Okay, so there's only one situation for convex. All right, so do the 3 rays for this. Ray number 1, from the object, you go parallel to the mirror. Bam, like that. Put arrows on it. Parallel. Now, here's what's not going to happen. If you're going to make a mistake, this would be it. Parallel, focal point. What's wrong with that? Does light go through a mirror? No, so you can't do that. But what you got to do, so you go parallel, and then what you're going to do is you're going to line this guy up with the focal point. So it's going to kind of be like this. I'm going to use my So it's like that. So he reflects off, but then I got to erase this. Right? Let me erase, because this should not be a solid line. That's not a light ray. Light does not go through a mirror. So it goes like this. This guy goes like this. He comes in parallel and then reflects off the mirror so that he lines up with the focal point. See that? He lines up with the focal point. Okay? So ray number 1, parallel, lines up with focal point, but doesn't go through the mirror. Reflects off the mirror. All right, what does ray number 2 do? Ray number 2, now look, is he going to go all the way to the focal point? No, but I'm just going to do that, but then I got to erase this, because he's not going to actually go all the way there, because what happens? He hits the mirror, so he comes in like this, so he's on his way to the focal point. See that? Bang. He's on his way to the focal point, but then what happens? Hits the mirror and goes parallel. Bang. Like that. So we got ray 1, we got ray 2. Will ray 1 and ray 2 ever cross? Never, ever, ever. So it's got to be virtual. So here's how virtual works. Well, if your eyeball, if you were right here, where would your eyeball think that this ray here came from? Straight back. Right? The dot, 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 that shows where light rays appear to be coming from. If your eyeball, erase this, if you were right here, so this is your eye, where would your eyeball think that this ray came from? Like that. We just found where the image will be. The image will be right there. Is that real or virtual? Virtual. Okay, cannot be placed on a screen. The third ray is a check. So what we do is we go like this. Oh my gosh, guys, this is too good. Look at this. You guys see this? Look at object to the center of curvature, but he's not going to make it all the way there. He's going to go like that. So he comes in, he's on his way to the center of curvature, reflects off. See this? That lines up with the center of curvature. Okay? So if your eyeball, if you were right here, if this were your eyeball right there, where is your eyeball going to think that this ray came from? There, they all agree. So what did we just find out about this? So this guy here, front or back? Back. Bigger or smaller? Smaller. Upright or inverted? Upright. Real or virtual? Virtual. Ray diagrams, like once you're good at them, look, hey, once you're good at ray diagrams, like if you're on a multiple choice test, if you're on the multiple choice part of the AP and they give you like a mirror question, you can just go like this. Just go parallel, focal point, focal point. Oh, it's going to be right there. You can just figure it out real quick. It doesn't have to be pretty. If they give it to you on the FRQ, then make it look nice.